let us discuss neural radiance field in some detail. Now it will be very easy for you to understand neural radiance fields because whatever we have studied until now, that foundation will help you in understanding neural radiance field. So neural radiance field is basically we have neural network which represent a scene as a continuous volumetric function. So we already saw the implicit representation of a 3D scene using neural networks. That is what is neural radiance field is, wherein we are representing a 3D scene in the form of neural network. So neural network is representing a scene as a continuous volumetric function. So instead of storing explicit geometry, the network memorizes the scene, the training, allowing it to input the density and color of any point in 3D space when queried. So this is the neural network. So we train it, and after training, we will give it. Okay, so for while training also, okay, now how we will train it is it will be supervised learning, wherein we will give the input. Input will be the coordinate of the point and the viewing direction, the camera pose. So that is the input, and output will be the properties like the pixel density and the color, and also it can include radiance and all that. So the idea is that first we have to train the model. So when we train, what we give it will tell is that okay, if this is the input, this has to be the output. So we will teach it, and once it will learn, it will learn that continuous volumetric function. So the neural network now it knows the mathematical continuous mathematical function which is representing a scene in which we are interested, which we want to render in real time. The novel view synthesis we have to do. That is the idea. So the input is like 5 dimension. Here the input is 5 dimension, that is x, y, z, and theta and phi. So the x, y, z is the spatial location, and theta and phi is the viewing direction. And the output is 4 dimension, that is the color, that is RGB, and the volume density, that is the sigma. Now, how it works, neural radiance field. The idea is that we shoot a ray from the camera through each pixel. So this ray will give us the viewing direction, because the idea is that whatever angle we want to generate the scene, we will point on that angle. Like we call it, we'll shoot the ray. And when we will shoot the ray, all the pixels falling in that region will be our point of interest. So we will sample all the points along the ray. And one by one, we will query the neural network at each point. So for each point, the coordinate of that point and the viewing angle will be the input to the neural network. It is the trained neural network, and it will generate the output. So we shoot ray through the pixels, we'll sample all the points along the ray like these points. We'll query, will give these points along with the viewing direction to the neural network one by one. And neural network will integrate colors along ray. So it will give us the output, the density and color, and then we will combine the points to render the object, and we call it the volumetric rendering. And now the good thing about is that let us suppose while training the neural network, we only gave it certain camera angles like front, rear, 45-degree, 60-degree, for example, like that. But when you will be using it, the trained model, it will give you like if you are focusing on 70-degree, it will render the scene like how the scene will look from when you will look it from the 70-degree angle. So novel view synthesis we will be able to achieve using neural radiance field, because in this module we are totally focusing on novel view synthesis. We already saw what it is, the application of it. It's a very powerful technique wherein scenes from unknown camera angles we can generate it, render it, synthesize it. And now it's very clear how we can accomplish novel view synthesis via neural radiance field. Now in neural radiance field, this ray marching plays a very important role. So ray marching means we will step along the ray, like we will keep on updating the ray. Like camera is focusing at an angle, then we will render that, then we will change the angle, like we'll keep on stepping the angle. So step along the ray. So that is ray marching. Step through space along a ray. Step through space along a ray is ray marching. So evaluate net, accumulate color and opacity. So ray marching is step through space along a ray. Okay, so ray marching is I am pointing to an object. So this is my ray. Along my ray, all the points will be the sample, and I will evaluate network repeatedly for all the points. I'll accumulate the color and opacity and I'll render the object, so the scene as looked from that angle. So typically along a ray, 64 to 256 sample per ray you can have the points. And for a frame, you should be having millions of rays, because this is to just one point of view. Then you'll shift a bit, then second angle, then third angle, like that millions of points you have to cover. And that is what the bottleneck is.